Let's say one day you look up at the sky and notice the moon. That pale, cratered, lonely rock, just hanging up there like the universe's least enthusiastic nightlight. And suddenly you get an idea. A big idea. A bad idea. The kind of idea that should require a license to think. You ask yourself, what if you built a slide from the moon to Earth? Yeah, a slide. Like playground slide, but space-sized. Welcome to the single greatest misuse of materials, money, and physics in humanity invented the concept of doing things for fun. First, some math. The moon is roughly 384,400 kilometers away from Earth. That's about 10 times the circumference of our planet. Imagine a slide so long that it could wrap around the Earth, not once, not twice, but 9.5 times. And now imagine it extending straight downward from the moon to your backyard like a giant noodle of death. If your average playground slide is 2 meters long, this thing is 192 million times longer, which is probably going to be a problem. Okay, so we need a material strong enough to build a structure that stretches nearly 400,000 kilometers. It needs to be flexible enough to handle orbital shifts, rigid enough to not collapse in space, and somehow light enough that Earth's gravity doesn't just snap it off like a spaghetti noodle. We'll need something that doesn't exist yet. Maybe magic. Maybe space titanium reinforced with hope and bad decisions. Either way, let's assume we have it. Sure, why not? Next problem, gravity. See, on a regular slide, gravity pulls you down. On the moon, gravity is only 1/6 as strong as on Earth. That means you could jump high, feel light, but it also means if you try to slide down something, you may not go anywhere at all. Without a strong gravitational pull, you just sort of sit there, on your cosmic death noodle. Forever. Great view, though. But let's say you bring a rocket booster, or give yourself a really solid push at the top. You need to reach the moon's escape velocity, which is about 2.38 kilometers per second, or roughly 8,500 kilometers per hour. That's faster than any commercial jet, car, or roller coaster ever built. You push off, and boom, you're sliding. At this point, you're no longer sliding. You're basically entering a controlled fall along the path of a glorified straw, a 384,000-kilometer-long straw, toward a spinning blue marble that's not exactly designed to welcome space-based commuters on fire. Because that's the next part. Re-entry. As you descend into Earth's atmosphere, you're going to hit some air. And by hit, I mean you're going to slam into it at speeds that would make meteors blush. Remember the friction you felt on the slide as a kid? Multiply that by a few billion, add plasma, and now you're basically becoming a shooting star. A flaming, screaming, human-shaped marshmallow. Unless, of course, your slide has been specially designed with re-entry shielding. Maybe some ablative layers, cooling systems, vents, reverse thrusters, seat warmers, anything to keep you from becoming barbecue. Assuming you survive, let's talk travel time. If you're moving at a modest 100 kilometers per hour, fast, but manageable without liquefying your organs, it would take you approximately 160 days to reach Earth. That's almost half a year of sliding. Half a year of leaning slightly backward in a tube, eating astronaut snacks, and desperately trying not to think about bathroom logistics. But wait, it gets worse. The Earth is spinning. While you're sliding straight down, the Earth is rotating beneath you at about 1,670 kilometers per hour at the equator. So if your slide doesn't account for this, you're not landing where you planned. You're overshooting the Earth like a cosmic dart. Better hope your slide curves like a racetrack and accounts for angular velocity. Oh, and don't forget to brake. Now imagine the structural issues. A slide this long has to deal with tidal forces from both Earth and the Moon. With gravitational tugging, the slide would constantly be under stress. It would also be exposed to space debris, micrometeorites, temperature extremes ranging from 120 degrees Celsius in the sunlight to minus 150 degrees Celsius in the shade, and whatever weird radiation the cosmos decides to throw at it. You also have to consider weight. The structure has to hold its own mass. If it's tethered to Earth, it'll get pulled down by gravity. If it's tethered to the Moon, the opposite. And if it's floating freely, it flops around in space like the saddest ribbon ever. Either way, it's a physics horror show. But let's pretend, just for fun, that you do it. You build it. You survive the slide. You land in your backyard with a GoPro, a jetpack, and a viral video. What now? Well, congratulations. You've just invented the most impractical mode of transportation in history. Your commute down from the moon takes 6 months. Going back up? Slightly trickier. Because you can't slide up a slide. Not unless you have rocket boots, a winch, and no sense of self-preservation. Could we use it for tourism? Maybe. Lunar pizza delivery? Cold, expensive, and possibly stolen by a passing satellite. TikTok content? Absolutely. Hashtag Moonslide Challenge. But in reality, it's not going to happen. Not now. Not in 100 years. The sheer logistics, physics, cost, and danger make it nearly impossible. The only reason to build a slide from the moon to Earth is to prove you're the main character in a sci-fi comedy written by the universe itself. Still, there's something magical about the idea. A human sliding from space, not in a spaceship, not in a capsule, but in a tunnel of absurd ambition. It's impractical, dangerous, ridiculous, and yet completely irresistible. And maybe that's what makes it beautiful. Just maybe keep your arms and legs inside the slide at all times. And wear a helmet. A really, really good one.